Good morning, students. Today we are going to see the topic atom and molecules second part. See, in our first class in atoms and molecules, we have studied about the characteristics of atoms. Already, what is an atom? We know that it is the basic unit of all matter. Then, according to modern atomic theory, atom is a divisible particle. It is the particle take part in the chemical reaction. Atoms of same element may differ in their mass number called isotopes, as some atoms of different elements may have same mass number we called isobars. Atoms of different elements may have same number of neutrons called isobars. And then atom of one element can be converted to atom of another element by transmutation method, by artificial transmutation method. And then these are all some postulates of modern atomic theory. Already we have studied in our last class. And then another important term, relative atomic mass. See, we are comparing the mass of atom of any element to the mass of carbon 12 atoms, that is 1 by 12 part of carbon 12 atom. That is the ratio between mass of atom of any element to the 1 by 12 part of mass of one atom of carbon 12 is known as relative atomic mass. See, for example, the relative atomic mass of hydrogen is 1. Relative atomic mass of carbon is 12. So, these are all we have studied in our last class. See, now today's topic about molecules. So, what is a molecule? A molecule is a combination of two or more atoms held together by strong chemical forces of attraction, that is chemical bonding. See, what is a molecule? The combination of two or more atoms. Two or more atoms of same elements or different elements. For example, hydrogen atom combined with another hydrogen atom form a molecule. One hydrogen atom combined with another hydrogen atom form a molecule. Say we call it as H2. Say it is a molecule. Say like this. Hydrogen combined with a chlorine. So again, atom of different elements, they form a molecule is called hydrogen chloride. Hydrogen chloride. See, like that, atoms of same element or atoms of different elements form a molecule. See, once again I repeat, a molecule is a combination of two or more atoms held together by strong chemical forces. That chemical forces is called nothing but chemical bonding. See, we know this different bonding, covalent bond, then ionic bond. Already we have studied in our 9th standard. Now, examples for molecules: H2O, helium, hydrogen. See here, in H2O, hydrogen combined with oxygen to form a molecule. But in the case of helium, it is a noble gas, we know. Here, then in helium molecule, there is only one atom. But anyway, it is a molecule. Then hydrogen combined with another hydrogen to form a molecule, say H2O. So these are all examples of some molecules: H2O, helium and hydrogen. See, we can classify the molecules according to their combination. What are the combinations? If a molecule is made up of similar atoms, then it is called a homoatomic molecule. If a molecule is made up of similar atoms, if a molecule is made up of similar atoms, then it is called homoatomic molecules. We say homo means same. So, for example, chlorine, nitrogen, hydrogen, helium, etc. Say a hydrogen atom combined with another hydrogen atom form a molecule. Both are same element. Like a chlorine combined with another chlorine atom, say form a molecule it is also the same element. So atoms of same element combine together to form a molecule. It is called homoatomic molecule. Homo means same. Like another thing, if a molecule is made up of atoms of different elements is called hetero. Hetero means different. So if a molecule is made up of atoms of different elements is called heteroatomic molecule. Example, carbon dioxide, water and sulfuric acid, etc. See here, in the sulfuric acid there are three elements. What are they? Hydrogen, sulfur, oxygen. Hydrogen, sulfur and oxygen. So atoms of different elements, they combine together to form a molecule. So it is a heteroatomic molecule. So like this, in carbon dioxide, carbon combined with oxygen. In water, hydrogen combined with oxygen. So atoms of different elements combined together to form a molecule is known as heteroatomic molecule. Then another term, atomicity. See, in a molecule there are number of atoms. See, that is called atomicity. How can we define? The number of atoms present in a molecule of an element is called its atomicity. Once again, the number of atoms present in a molecule is called its atomicity. For example, already see, in carbon dioxide, carbon combined with oxygen. See, there are two elements, one carbon atom and two oxygen atoms. So totally in this carbon dioxide molecule there are three atoms. Like this, number of atoms present in a molecule is called atomicity. See, for example, in hydrogen we write hydrogen H2. It means H2. There are two atoms present in a molecule of hydrogen. There are two atoms of hydrogen present in a molecule. So atomicity of hydrogen is 2. We call it as diatomic. Already we know that if for mentioning single, that means one, we use mono. 2 di, 3 tri. 1 mono, 2 di, 3 tri. More than 3 we call it as poly. We use the word poly. Like this, here the hydrogen molecule, there are two atoms, so the atomicity of hydrogen is 2. We call it as diatomic molecule. So again another one, helium. See, it's a noble gas. In a molecule of helium there is only one atom, so it is called monoatomic molecule. The atomicity of helium is 1. Like all the metals, the atomicity of metal is also 1 because there is only one atom in a molecule. Next, ozone. O3. See, in a molecule of ozone there are 3 oxygen atoms. So 3 oxygen atoms, we use it as tri. So triatomic molecule. The atomicity of ozone is 3. So it is called a triatomic molecule. Next, hydrogen chloride. See, hydrogen combined with chlorine to form hydrogen chloride. See, one hydrogen atom combined with one chlorine. So automatically there are two atoms in hydrogen chloride molecule. So the atomicity is 2, but the elements are differ. So we use heterodiatomic molecule. Heterodiatomic molecule. Next, ammonia. The formula of ammonia is NH3, 1 nitrogen, 3 hydrogen. Combined, how many atoms? There are 4 atoms. So more than 3, no? So we use the word poly. More than 3, we use the word poly. So poly, two different elements, nitrogen combined with hydrogen. So polyheteroatomic molecule. Polyheteroatomic molecule. The atomicity is 4 for ammonia. Then sulfur. It is the same element. In a molecule of sulfur there are 8 atoms. So it is polyatomic. Next, another important term, relative molecular mass. What is relative molecular mass? Just like atom, to measure the mass of a molecule, we are comparing the molecule of any element with the carbon 12 atom. With the carbon 12 atom. So how can we define the relative molecular mass of a molecule is the ratio between the mass of one molecule of the substance to 1 by 12th mass of an atom of carbon 12. Just like relative atomic mass. There we are comparing mass of an atom with 1 by 12 part of carbon 12 atom. Just like here we are comparing mass of a molecule of an element to the mass of 1 by 12th mass of carbon 12 atom. It is called relative molecular mass. That is, the relative molecular mass of a molecule is the ratio between the mass of one molecule of the substance to 1 by 12th mass of an atom of carbon 12. So, just like relative atomic mass, it is a ratio. So, relative molecular mass has no unit. So, it is when it is expressed in grams, it is called gram molecular mass. See, let us see in this diagram picture. In the atom of oxygen, there are two oxygen atoms combined together to form a molecule. It is called homodiatomic molecule. Say in the oxygen molecule, there are two atoms of oxygen. They combine together. So it is called homodiatomic molecule. See here another picture. Ozone. There are three oxygen atoms present in it. They combine together form a ozone molecule. So it is also homotriatomic molecule. Homotriatomic molecule. See like this. Here in this picture, when hydrogen combine with chlorine form hydrogen chloride. So two different elements combine together, but anyway the number of atom present is 2. So it is called heterodiatomic molecule. In the case of water molecule, there are two hydrogen atoms, one oxygen. See the number of atom present is 3. So it is called heterotriatomic molecule. Heterotriatomic molecule. There are 3 atoms of different elements, 2 hydrogen and 1 oxygen. So 3 atoms we call it as tri, different elements, so hetero. So heterotriatomic molecule. So in this activity, classify the following molecules based on their atomicity and fill in the table. See how there are some elements and compounds have given. See that. Fluorine, carbon dioxide, phosphorus, sulfur, ammonia, hydrogen iodide, sulfuric acid, methane, glucose, carbon monoxide. We differentiate homo and hetero. See, atoms of same elements, they combine together form a molecule, means it is homo. Fluorine, it is a homo molecule. Carbon dioxide, it is a hetero molecule. Phosphorus, homo. Sulfur, homo. Ammonia, different elements, so hetero. Hydrogen iodide, different elements, hetero. Sulfuric acid, different elements, hydrogen, sulfur and oxygen, so hetero. Methane, carbon and hydrogen, hetero. Glucose, carbon, hydrogen, oxygen, hetero. Carbon monoxide, carbon and oxygen. So it is hetero molecule. But how can we find the atomicity? See, in fluorine, how many atoms are there? 2 atoms are there. So diatomicity. So that is diatomic molecule. It is same element, so homo diatomic molecule. Then carbon dioxide. In carbon dioxide, carbon and oxygen, but there are 3 atoms, so Then different elements, hetero-triatomic molecule. Hetero-triatomic molecule. Phosphorus, same element. Number of atoms present is 4. So polyhomoatomic molecule. Sulfur, there are 8 atoms present in sulfur. So polyatomic molecule. Polyatomic molecule. Ammonia, totally 4 atoms are there. So more than 3 polyheteroatomic molecule. Polyheteroatomic molecule. Hydrogen iodide, 2. There are 2 atoms are there. So it is different elements. So heterodiatomic molecule. Heterodiatomic molecule. Sulfuric acid, totally 2 plus 1 plus 4. So totally 7. More than 3. So polyheteroatomic molecule. Polyheteroatomic molecule. Methane, there are 5 atoms. So more than 3. Again polyheteroatomic molecule. Polyheteroatomic molecule. Glucose, polyheteroatomic molecule. Carbon monoxide, there are only 2 atoms. So heterodiatomic molecule. Heterodiatomic molecule. See, is it clear now? Let us see another topic. How can we measure the relative molecular mass? Already we know this. The number of atoms present in a molecule is atomicity. Now let us calculate the relative molecular mass of sulfuric acid. Sulfuric acid. The molecular formula of sulfuric acid is H2SO4. H2SO4. How can we calculate? See, relative molecular mass of sulfuric acid is equal to, how many atoms of hydrogen is here? 2. So 2 into mass of hydrogen. What is the mass of hydrogen? We know it is 1. Then sulfur atom, 1 into mass of sulfur. An oxygen atom, there are 4 atoms. So 4 into mass of oxygen. Mass of sulfur is 32. Mass of oxygen is 16. So substitute the values of mass of hydrogen, sulfur and oxygen in this formula. That is 2 into 1. Mass of hydrogen is 1. 1 into mass of sulfur, 1 into 32. Then mass of oxygen, 4 into 16. So we are calculating 2 into 1, 2. 1 into 32, 32. 4 into 16, 64. So we are adding 2 plus 32 plus 64, 98. When it is expressed in grams, we call it as gram molar mass. Molar means nothing but molecule. See, molecular mass or molar mass, 98 grams. For sulfuric acid, the molar mass of sulfuric acid is 98 grams. Let's see another example. Calculate the relative molecular mass of H2O, water molecule. Here, the atomic mass of hydrogen is 1, oxygen is 16. So substitute the values 2 into, there are 2 hydrogen atoms. So 2 into mass of hydrogen plus 1 into mass of oxygen. So 2 into 1 plus 1 into 16, totally 18 grams. So the molecular mass of water molecule is 18. The molar mass of water is 18 grams. Then we can differentiate atom and molecule. So atom, already we know this, it is the very smallest particle. Atom is the smallest particle of all element. Atom is the smallest particle of an element. And atom does not exist in free state except in a noble gas. Noble gas, we know this, the 0 group elements. What are they? Helium, neon, argon, krypton, xenon, radon. These are all noble gases. All these gases, they exist in free state. So other atoms, they do not exist in free state. So atom does not exist in free state except in a noble gas. Except some of noble gases, other atoms are highly reactive. Highly reactive means they easily react with other elements. That means already we know this. Atom is it takes part in the chemical reactions. So except noble gases, all the other atoms they highly reactive. Atoms does not have a chemical bond. So and then like molecule. A molecule is the smallest particle of an element or compound. Molecule exists in free state. It can exist in free state. Molecules are less reactive. Comparing atoms, molecules are very less reactive. Atoms in a molecule are held by chemical bonds. See, molecules are formed by the combination of atoms. No, so they are combined with by chemical bonding. So these are the some differences between atoms and molecules. Once again I repeat, an atom is the smallest particle of an element. An atom does not exist in free state except in noble gases. Except some of noble gas, other atoms are highly reactive. Atom does not have a chemical bond. In molecules, a molecule is the smallest particle of an element or compound. A molecule exists in a free state. Molecules are less reactive. Atoms in a molecule are held by chemical bonds. It is a very important to mark. And then another important term, person composition. What is person composition? See, in a particular compound, the percentage of the particular element in this compound can be calculated in 100 grams of the compound. See, how can we define it? The percentage composition of a compound represents the mass of each element present in 100 grams of the compound. The percentage composition of a compound represents the mass of each element present in 100 grams of the compound. See, let us see an example. Find the mass percentage composition of water molecule, that is H2O. Here there are two elements, hydrogen and oxygen. You have to calculate mass percentage of hydrogen as well as oxygen. See, what is the formula? Mass percentage of an element is equal to mass of that element in the compound. Mass of that element in the compound by molar mass of the compound. What is molar mass? Molecular mass of water molecule here. See, how can we calculate the molecular mass, molar mass or molecular mass of water? H2O formula. The value of mass of atom of hydrogen is 1. Mass of oxygen is 16. So 2 into 1 plus 16, totally 18 grams. The molecular mass of water molecule is 18 grams. So it should be multiplied into 100. How? Mass of percentage of hydrogen is equal to, see, in this compound the mass of hydrogen is 2. The whole mass, that is molar mass, is 18. So into 100. 2 by 18 into 100. While you are simplifying this, you will get 11.11 percentage. Like mass of oxygen. The mass of oxygen in this compound is 16 by total mass, that means molar mass is 18 into 100, you will get 88.89 percentage. Like we can do some other sums. Calculate gram molar mass of carbon dioxide. See, how can we calculate carbon dioxide? So do it yourself. The value of atom of carbon is 12, oxygen 16. So 12, 1 into 12 plus 16 into 2. Just to calculate like this. Calcium phosphate, Ca3PO4 twice. Ca3PO4 twice. Here there are 3 calcium atoms, 2 phosphorus atoms, 4 into 2, 8 oxygen atoms. So calculate for calcium, phosphorus and oxygen. Do it yourself. Then calculate the percentage of sulfur in sulfuric acid. See, formula of sulfuric acid, H2SO4. Here total, first find the molar mass of sulfuric acid. Already we have found it is 98. So in that, what is the percentage of sulfur? See, sulfur, the atomic mass is 32. So 32 by 98 into 100. In such a way, calculate the percentage of sulfur in sulfuric acid, and then calculate gram molar mass of carbon dioxide and calcium phosphate. See here, the value of calcium 40, then phosphorus 30, oxygen 16. See, just to calculate 3 calcium atoms, 2 phosphorus and 8 oxygen. Do it yourself as a homework. See, in our next class we are going to see mole concept and Avogadro's hypothesis, and how can we calculate the moles in our next class. Thank you.